All right, now I'm going to talk you through example 5. So I've already written out what's going on because I don't want to spend my time writing and talking. So I want to talk it through you and then point out how I came up with what I wrote down. So your parents invest $10,000 in a college fund on the day you're born. Every year on your birthday, they add $2,000, but the fund is also earning 8% interest compounded annually. How much will be there on the day you turn 18? So let's think about what happens. There is little baby you, and you're like, ah. And your parents are like, oh, we're so happy, but babies cost money, and so we're going to put $10,000 in the bank right now. And then you turn 1 year old, and there's cake, and there's a candle, woohoo! And your parents are like, okay, this money has been in the bank for a year. It earned 8% interest. So my $10,000, so 10K, has earned its 8% interest, so 100% plus 8%, and then we're adding $2,000. And then you turn into a toddler, and there you are. And now all of that money has earned 8% interest. So all of that gets your all 100% plus another 8%, and then your parents put in another $2,000. So at the end of year 1, you had your $10,000 times the 1.08% interest, and we add $2,000 to it. But so if we think about that, at the end of every year, we are multiplying by 1.08 and then adding the 2,000. So should this term actually needs its plus 2,000 for my first setup. So my end of my first year, so the end of the first year living, the day that you turn 1, that initial investment earned its 1.08. It earned its 8% interest, and there's 100% of it still there, and your parents added 2,000. At the end of that year, we earn our interest and we add 2,000. So this is my recursive sequence. If I write out what's happening, so here's where we turned 2. So all of this money earned its interest and we added 2,000. Well, if I expand this equation, I'm going to have 10,000 times 1.08 squared plus this 2,000 times 1.08 plus another 2,000. So I could say that's 10,000 times 1.08 squared plus I can take out the 2,000. So here I had 2,000 times 1.08 plus 2,000. If I factor out the 2,000, I've got 1.08 plus 1. All right, so then at the start of your third year, when you turn 3, all of this money, so there's all of that money, gets 1.08%, 100% plus the 8% interest, and we add 2,000. Again, if I expand this and rearrange it, I'm going to have 10,000 times 1.08 cubed plus 2,000 times 1.08 squared, 2,000 times 1.08 plus another 2,000. So at the end, on the day we turn 18, that $10,000 will have earned its 8% interest 18 times. So this is just a constant value. It's not any sort of sequence. It's just a single number, 10,000 times 1.08 to the 18th. But the 2,000, well, that first amount of 2,000 will have earned the 8% interest 17 times. After you turned 2, that 2,000 is going to earn its interest 16 times, and so on and so forth. So inside that parentheses there, I see a geometric series with a first term of 1, an R value of 1.08, and I see inside of there 18 terms. So on your 18th birthday, another 2,000 gets added. That's happened every birthday, and you've had 18 of them. If I think about this 17, well, I've got 17, 16, 15, 14, down to 1. So 1 to 17 as my exponents is 17 terms, plus this term here is my 18th term. I know, of course, that sum to 18 is going to be the first term times 1.08 to the 18 minus 1, all over 1.08 minus 1. Of course, that sum is being multiplied by 2,000. And then I'm going to add my 10,000 times 1.08 to the 18th. I've already done that in my calculator. And wow, your parents are ready to pay for your college education, assuming you go to someplace that's around the $30,000 mark. So you've got $114,860, basically $861.